The figure below shows a circle inscribed in a square. To the nearest percent, what is the probability that a dart thrown at the figure will land in the shaded region? So essentially what we're trying to calculate here is the area of the shaded region divided by the area of the whole thing, right? The area of the shaded region out of the area of the whole thing. And we could use variables to do this, get a big nasty equation with a bunch of x's, but instead, why don't we just make up our own numbers? And the reason we can do that is because the problem has not specified how big or small this shape is, right? So we can just pick our own numbers here. Let's say, to make it easy on ourselves, that this has a radius of 1. This circle has a radius of 1. That means it's going to be 1 on that side as well. And that means that the square is going to have side lengths of 2 and 2. Okay, well, the area of the total, right, this whole figure, is just going to be 2 times 2, or 4. But how do we calculate the area of the shaded region? Well, we can do that by exclusion. So if we start with the big picture, right, we have this big square right here. If we subtract out the area of the circle inside, then we're left with these 4 little corners right here. And these 4 corners, as we can see, are equal to each other. So we can just divide it by 4, and we're left with this. So let's do it. The area of the whole thing, right, is 4. And I'm going to subtract out the area of the circle. Well, what is that? The area of the circle is pi r squared. The radius in this case is 1, so it's just going to be pi times 1 squared, or pi. And when I do that, I get something very close to 0.86. Okay, so I've subtracted out this circle, and I'm left with these 4 corners. Again, this corner is equal to these other 3, so we can just divide by 4, and I'm left with that. Let's divide 0.86 by 4, and when I do that, I get something very close to 0.21. Okay, so I get 0.21 over 4, and I do that. It comes very close to 0.05, or 5%.